In our experiment, we wanted to measure the head circumference to height proportion against the complex reaction time of 13 to 15-year-olds in our school. So to do that, we created a computer program which flashes a bright recognizable colour, so 1 of 6, and for example red, and then the candidates had to press the corresponding colour's first letter, for example R for red, in order to stop the timer, and that would be their reaction time. The 6 colours that we used were red, blue, green, yellow, purple and orange. So a few candidates have had difficulty distinguishing between yellow and orange, and there was one colourblind boy who had trouble distinguishing between red and green, but other than that there weren't really that many problems. So to measure the head circumference, we passed a tape measure around the widest part of the temporal bone in the skull, as you can see from this clip, and that gave us the most accurate measure of the widest part of the head, and we did this for all of the heads, so that was a constant. So we usually took out 2 candidates at a time, so one candidate would be inside a quiet room doing the computer test, and then one candidate would be outside in a different quiet room to have their head circumference and height measured. As you can see from this clip, height was measured kind of roughly with the book to try and get as accurate as possible.
Our experiment combined 2 findings together to see if brain circumference was related to G. So G is a general factor of cognitive intelligence, and it's a component of IQ, so you can think of, in your head, consider it as IQ. So we're measuring complex reaction time as a measure of G, and numerous studies have found them to be quite closely associated. So in 2006, Whittleston, he studied 100 post-mortem brains, and he found that when they were alive, the higher they scored on the Wechsler Adult Intelligence Scale, the larger the post-mortem brain volume. Well, brain volume is closely associated with head circumference. So for instance, when you're born, the nurse will often measure your head to see if your brain's developed normally. So we're measuring head circumference as an indicator of brain volume because of the resources available. So overall, our experiment will measure head circumference as an indicator of brain volume and complex reaction time as an indicator of G. What are the limitations of the experiment?
I think that pupils who can touch type would be much quicker at pressing the key, and so for me, because I can't touch type, my reaction time was much slower, as I had to figure out where the key was and then press it, so that would give me a longer reaction time.
What did you like about the experiment?
I really liked it. I thought it was really fun. It was very well conducted, as there was no distractions because the room was very quiet. It was good that we were given 5 practice rounds, which gave us a chance to get used to the game. And yeah, I thought it was really fun.
So for our results, first we ruled out any anomalies because it usually meant that the candidate had pressed the wrong key, and so the timer had kept going, so it wasn't actually their reaction time, it was just how long it took for them to find the right key. And after that, we conducted the Spearman's run coefficient correlation statistical test to find whether our results were significantly correlated, and we found that they weren't. So we had a result of minus 0.05, so there's a very slight negative correlation between reaction time and head circumference proportional to height, which is what we expected. So a bigger head means you have a shorter reaction time, but the statistical tests show that it's not a significant correlation. And I think that one explanation for this is that we didn't have enough candidates to test on, and we only had 31. So I think if we had maybe hundreds of candidates, we would have had a more significant correlation. Thank you for watching our video. We hope you learned something new, and if you have any questions, you can ask us now.